the classes for those who could not attend the class. So, as I've already told you, we are going to discuss all the MCQ questions. Okay, so the first, there are 60 questions in total. The first phase of questions are a bit difficult. That's why I'm going to do those first. So the remaining, that means I'm going to do 20 questions. Those questions are theoretical based. Is that clear? And the remaining 40 questions, the remaining 40 questions are all practical. That means the questions which you have done similar types of in class 10 also, finding out the values of x and y, all those. Don't worry, I'll do those also. But this particular class, the first 20 questions are very important for you. Okay, so everyone, let us begin. So the notes I've already sent it to you, so you need not copy. I've already sent in the group right now. Okay, this is chapter number 6, matrices, question number 60. So we start off with the first question, everyone. So you can, I hope you all can see the board clearly. So question number 1 says, a square matrix is invertible if and only if A is number 1 a null matrix, number 2 a singular matrix, number 3 a non-singular matrix, and none of this. So we need to understand the meaning of these. Null matrix mean everything 0, singular matrix means determinant equal to 0, non-singular means determinant not equal to 0. So what they are asking us, what is the condition, what should be the characteristic of A for A inverse to exist? So obviously for that I need to know the formula for A inverse. What is the formula for A inverse? It is adjoint A divided by determinant A. I can write DETA or modulus A. So this means the same. So from here you can clearly see that if, number 1, if determinant A equal to 0, if determinant A equal to 0, that means any number divided by 0 is infinity. So A inverse does not exist. A inverse does not exist. Does not exist. And determinant equal to 0 means singular. And if determinant A is not equal to 0, then obviously A inverse exists. Because if it's not 0, then you get a number. That means we can find out A inverse. Is that clear? So what is the right option? The question says, what should be the characteristic of A for A inverse to exist? For A inverse to exist, so for A inverse to exist, the determinant cannot be equal to 0. So a determinant cannot be equal to 0 means determinant, the matrix A is non-singular. Non-singular. So the right option is C, non-singular. Okay. Question number 2. Question number 2 says, if A is an invertible matrix, that means inverse exists, of order 3. So it's 3 cross 3. So the order is 3, n equal to 3. And determinant A is given to be 5. I have to find the determinant of the adjoint. So this type of question you can expect many questions of this form this year. Is that clear? So for this you need to know the formula, a relation between the determinant of an adjoint and the determinant of the matrix. The relation is, everyone, the determinant of an adjoint, the determinant of an adjoint is determinant of A to the power n minus 1. So what is the determinant of A? This is 5. And what is n? N is the order. So 3 minus 1 is 2. So what is the determinant of the adjoint? It is 25. So the right option is A, that is 25. Is that clear? So I will be helping you solve all these questions. So if you do 60 questions on matrices, then 16 marks is for sure. Okay, you can surely get 16 out of 16 from this. Okay, so question number 3, we move on to question number 3. The first part, as I've already told you, the first 20 questions are theoretical based. That means you need to know some formulas, understand the concept, but the remaining 40 questions are all what do you call sums. So it's easy for you to do those questions. Okay, so now this is question number 3, everyone. Question number 3. So tomorrow also I will do the remaining question. Question number 3. If A is a square matrix of order n, so again question number 3, the order of the matrix is 3, that means 3 cross 3. It's a square matrix, 3 rows and 3 column. Then the value of I have to find the value of, what does this mean? Determinant 2 into A. I have to find the value of this determinant 2 into A. And it is given that the determinant A is 4. The value of the determinant A is given to be 4. So in order to answer this also, you need to know the property of determinant. Everyone look at the board. So the property of determinant says uh, determinant of a matrix into a scalar, k is a scalar, then k comes in front to the power n minus 1 into the determinant. N minus 1 into the determinant. So let me apply the same formula. The scalar is 2. So what do you get? 2 to the power n minus 1. What is n? N is 3. 3 minus 1 is 2 into what is determinant A? Determinant A is 4. So what do you get? What do you get the answer to be? This is 2 to the power, oh sorry, this is 2 to k to the power n, not k to the power n, not n minus 1. I'm so sorry, n is 3. So 2 cube is 2 to the 4, 4 to the 8. So 8 4 is, how much will it give? Will give 32. So 8 4 are 32. So if you see a scalar and a matrix, the scalar comes out to the power n. Is that clear? So this is question number 3. Question number 4 says, everyone, question number 4 says, I'll just stop this. So the solutions I've already sent it in the group, so you need not copy this. If you want, you can take a screenshot also, no problem. The video is being recorded. So tomorrow we are going to do the remaining questions. Tomorrow we are going to do the remaining questions. Okay, so question number, this one is question number 4. Okay, question number 4, everyone. If A is a square matrix of order 3, so again n, the value of n is 3, the value of n is 3, okay, and then such that adjoint, determinant of adjoint A, determinant of adjoint A is given to be 64, determinant of adjoint A is given to be 64, I have to find the value of determinant A. So obviously there is a relation between the determinant of a matrix and the determinant of the adjoint of the matrix. So what is the relation, everyone? Determinant of the adjoint of the matrix is equal to determinant of the matrix to the power n minus 1. So what is adjoint? Determinant of the adjoint, this is what, 64. We don't know this. Determinant of A, what is n? N is 3, so 3 minus 1 is 2. 2 comes this side, becomes square root. So square root of 64 is what? Plus minus 8. So we take into consideration both the values because a determinant can be positive as well as negative. A determinant can be positive as well as negative. Is that clear? So this one was question number this one was question number 4. Now question number 5 says, if A and B are non-singular matrices of the same order, then AB and BA are also non-singular. This is directly theoretical. Non-singular means determinant not equal to 0. Determinant not equal to 0. So obviously if the determinant of one matrix is not equal to 0 and the determinant of the second matrix is also not equal to 0, then when you multiply those two matrices, then the product matrix also, the determinant will not be equal to 0. That is what they are asking us. Okay, so now we move on to question number 6. Question number 6 is, if A is a square matrix, what is a square matrix? A square matrix is a matrix whose number of row and number of column are equal. So it's either 2 cross 2 or 3 cross 3. Is that clear? Not more than that. So in this case, it is 3 cross 3. It is 3 cross 3. So n equal to 3. I have to find out the value of determinant k into a. So k is a scalar. You know what's going to happen. What is going to happen? Please tell me. K into a. What's going to happen? The k comes out to the power n into determinant a. And what is the value of k? What is the value of n? The value of n is 3. So k cube into determinant a. The value of the determinant was not given, so option number C is the correct answer. So this is question number 6. This is question number 6. Okay, question number 7 says, everyone, question number 7 is important for you all. Question number 7 is important for you all. Not this question, but I have just made one question and I've shown it there also. So I'll just give you another example. So see, question number 7 says, everyone, question number 7 says, determinant of a to the power minus. what is the determinant of A inverse? They are asking us to find this. So determinant of A inverse. So the property of inverse says determinant of A inverse can be written as determinant of A to the power minus 1. And how do you make it positive? You take it to the denominator. So 1 by determinant of A. So this is the right option. That means option number B is the correct answer. But you don't expect such easy question. So what they will give you is a question for 2 marks based on this theory. Okay, so they will give you a matrix. Let us say 3 1 2 2. Let us say 4, or rather let us say 3 only. Okay, so they'll give you a matrix 3 1 2 3, and they will tell you to find the determinant of A inverse. So they will tell you to find the determinant of A inverse. If you don't know this formula is simple. This formula says determinant of A inverse is nothing but 1 by determinant A. If you don't know this formula, what you are going to do is you will find A inverse, because you know how to find A inverse. We have done lots and lots of questions based on that. So the second part, that means from 20 to 40 questions are based on this only. You know how to find A inverse. The formula is adjoint divided by determinant. You know the formula, yes or no? So what you will do is you will use that formula and get A inverse. After that, you find out the determinant of that. I'm not saying that you're not going to get the answer. You will get the answer, but it will take a long time. If you know this property, then the solution becomes simple. You simply have to find determinant A, isn't it? So what is determinant A? It's a 2 cross 2 matrix. How do you find the determinant of a 2 cross 2 matrix? You cross multiply. 3 3s are 9, minus 2 1s are 2. So what is the value of the determinant A? 7. So therefore determinant of A inverse will be 1 by determinant A, and that is equal to 1 by 7. See, answer is same. This is a technique. The other one is the concept based, the long method. I hope you understood what I'm trying to explain out here. So once again, if you don't know the relation between determinant of A inverse and determinant of A, then you'll end up finding A inverse and then finding the determinant, and that is a very long and difficult process. Is that clear? So this one was question number 7. Okay, now we move on to question number 8. Question number 8, we have to find out the inverse of a 3 cross 3 matrix. So when we did matrices, we did lots and lots of questions of this form. Offline, if you like normal mode of examination, that means out of, if you had examinations out of 80, then you would get to find out the inverse of a 3 cross 3 matrix. I will teach you this. So question number 8, everyone. If A, B, C are non-zero real numbers, then the inverse of the matrix, I have to find out the inverse of this matrix. Capital A, I have to find the inverse of this particular matrix. I have to find the inverse of this particular matrix. Capital A is equal to A 0 0 0 B 0 0 0 C. So I have to find the inverse, and you know the inverse. How do you find the inverse? Adjoint A divided by determinant A. This is the formula, isn't it? So let me teach you how to find the determinant. Okay, normally how do you find out the determinant of a matrix? You expand any row or any column, isn't it? So what do? You take A, cover the row and column, then you take this, then you take this, and so on. But there is a technique. What type of matrix is this? Can anyone tell me? What type of matrix is this? If I tell you to identify, this is a special type of matrix. It's a square matrix for sure, because number of row and number of column is same. Okay, and this is a special type of matrix. It is called a diagonal matrix. What is it called? A diagonal. Diagonal means only the diagonal elements will be non-zero, the rest is going to be zero. So if you come across a diagonal matrix, then the determinant of the diagonal matrix will be product of the diagonals. That's it. You don't have to expand anything, and this is applicable only for a diagonal matrix. So determinant of a diagonal matrix is nothing but the product of the Product of the diagonals, that means ABC. See, you, what do you call, you save so much time. If you didn't know this, then you would end up expanding the determinant, which I'll be teaching you in the next question, how to expand a determinant. Okay, you got the determinant. Okay, now I need to find the adjoint. And you know, to find the adjoint, I have to write down the cofactor of each and every element plus the transpose. Cofactor means, what is the cofactor of A? Cover the row and column. So when you cover row and column of A, so what is left? B, 0, 0, C. So this is the cofactor. And luckily, the diagonal matrix, the adjoint is also diagonal. Keep that in mind. For a diagonal matrix, the adjoint is also diagonal. That means these numbers cannot be anything. It has to be 0. So you don't have to find out the cofactor of this. So see, time, you saved time out here also. Similarly, this is 0. What are the cofactors of B? Cofactors of B, cover the row and column. So B is in second row and second column. So you are going to get A, 0, 0, C, 0, 0, 0, and this becomes cofactor of C is A, 0, 0, B. Yes. So simplify this. Now you need to check the sign also. Plus, no need to write minus, plus, minus, plus, minus, plus, minus, plus. That means we need not write down the signs also. So how do you open this? B into C is BC minus 0 is BC. This becomes 0, 0, 0. A into C is AC minus 0 is AC. 0, 0. A into B is AB minus 0 is AB. Take the transpose of this. Transpose means row changes to column. So the first row, BC 0, 0, now write as BC 0, 0. Second row, 0, AC 0. And third row, 0, 0, AB. So we see that the matrix and its transpose is equal. So this is called a symmetric matrix. Please keep that in mind. This is called a symmetric matrix. So you got the adjoint. Now it's time to find out A inverse. So what is A inverse, everyone? A inverse is the adjoint, which we already found out, divided by the determinant. Determinant is ABC. So divide each and every element with ABC. So BC divided by ABC will be BC, and BC gets cancelled. So we are left with 1 by A. 0 divided by ABC is 0. 0 is 0. 0. 1 by B, 0, 0, 0, 1 by C. So the right answer is A goes up, becomes A to the power minus 1, 0, 0, 0, B to the power minus 1, 0, 0, 0, C to the power minus 1. So this is the value of A inverse. So the right option that I see out here is option number A. So this is how you find out the inverse of a 3 cross 3 matrix. I'm going to teach you how to find out the inverse of a 2 cross 2 matrix also, but in this case I use some techniques. And what were the techniques? The determinant of a diagonal matrix is the product of the diagonals. Next, the adjoint of a diagonal matrix is also a diagonal matrix, so we don't have to find out the cofactor of second term, third term. What is the position of this? I've explained this many times in the first class. The position of this is in the first row and the second column, A12. This is first row, third column, A13. So we don't have to find the cofactor of this. Is that clear? So please, if you want, you can take a screenshot. So this one was question number 8. So 12 more questions to go. But the remaining questions are not that. It's theoretical based. So the formulas which I had given it to you, remember the 20 formulas which I had given it to you, based on that only all these questions are to be solved. Okay, now we move on to question number 9. Question number 9, I've already done this. Yes, I've already done this, I remember. Okay, so I'll do question number 10, similar type only. Okay, question number 10 says if A equal to, this is cos x, sin x, 0, this is sin x, cos x, 0, 0, 0, 1 is a singular matrix, find the value of x. So what you need to know is the meaning of a singular matrix. So what is the meaning of a singular matrix? Singular matrix, anyone? Singular matrix means the determinant of this matrix equal to 0. Okay, so you know that I need to expand this determinant, but out here also, if you expand the determinant to the first row, then the calculation becomes difficult. Reason, if I expand the determinant through, because I have already told you a determinant can be expanded through any row or any column. If you expand the determinant through the third row or the third column, the solution is going to be simple. Why? Because the third row contains two elements equal to 0. So you don't have to expand through this and this, because 0 into anything is 0, 0 into anything is 0. So you just have to expand through 1. So this also will help you save time. So what do? We expand through we expand through row 3, but please don't forget to check the sign. So this is positive, negative, positive doesn't matter, negative does not matter, positive also does not matter. So what are the cofactors of 1? The cofactors of 1 are cos x, sin x, sin x, and cos x is equal to 0. Okay, now how do you find out the determinant of a 2 cross 2? So you cross multiply, cos x into cos x will give us cos square x, minus in the middle, sin x into sin x will give us sin square x in the middle. So whenever you see cos and sin, you always convert that into tan, because laws of mathematics says in order to find the value of an unknown, there must be only one unknown. How can you find out the value of cos and sin together? So convert into a single variable. Is that clear? So how do you convert this into a single variable? So negative sign goes, that sign becomes positive. Divide everything by cos. So this becomes 1. Sin by cos becomes tan. Square comes, this sign becomes root. So tan x equal to root 1. So tan x equal to 1. I need to find out the value of x. So I need to convert the right also in terms of tan. So 1 can be written as tan 45. So tan and tan gets cancelled. So x equal to pi by 4. X equal to pi by 4. So the right answer that I see is question number 10, subdivision B. Question number 10, subdivision B. Okay. So I'll just drop this. Now we just got 10 more questions to go. Okay, everyone, pay attention. Okay, next question is question number 11. Question number 11. So always keep in mind in matrices, please, always keep in mind in matrices that whenever there is a product, the what do you call, the position of the matrices changes. For example, AB transpose, AB inverse, and adjoint of AB all follow the same concept. I've already told you the transpose goes inside, but the position of the matrices changes. So it becomes B transpose, A transpose. Inverse goes inside, but it becomes B inverse, A inverse. Similarly, adjoint goes inside, but it becomes adjoint B into adjoint A. So this was the question number 11. This was the question. Okay, question number 11 is this. Okay, question number 12, a bit difficult one, important for you. Equation is given a square minus a plus I equal to 0. I have to find a inverse. So we know how to find the inverse from a function, from an equation. What you need to do is you need to multiply both sides with a inverse, because I need to get a inverse. So how do you get that? Look up a square, negative goes that sign becomes positive, and positive I goes that sign becomes negative. Now what do? You multiply both sides with a inverse. So when you multiply both sides with a inverse, you get a inverse into a square, a inverse into a minus I. So I can write a square as a into a inverse into a, you're multiplying it, distribution law, a inverse into identity. And now we are going to use two properties. What is a inverse into a? You already know a and a gets cancelled, one, and in matrix it is called identity. So IA, again a inverse into a is your identity minus a inverse into I. Next property, any matrix into identity will give you the matrix itself. Again, any matrix into its identity will give you the matrix itself, A inverse. So bring A inverse this side. So you get A inverse equal to capital I minus A. So the inverse of this particular equation is capital I minus A. So this is question number 12. So the right option that I see is option number B. Option number B. Okay. So I'll just rub this. The solutions have already been sent in the group. The solutions have already been sent in the group. So this was question number 12. Okay, now let us move on to question number 13. Okay, 13 is also very important for you. Question number 13. Question number 13 is given the matrix A is K0, 0, 0, K0, 0, 0, K. I have to find, this is it's a square matrix 3 cross 3. I have to find the value of the determinant of adjoint A. Now this one also, if you do it the normal way, the concept base is going to be very, very long, because the matrix A is given, so it's a diagonal matrix, so you find out the adjoint of this. So to find out the adjoint of the diagonal matrix, it's again a diagonal matrix, a long process, isn't it? After that, you find out the determinant. But please don't do that, because we already know there is a direct connection between the determinant of an adjoint and the determinant of the matrix. So I can easily find out the determinant of A because it's a diagonal matrix. So the determinant of a diagonal matrix is the product of the diagonals. So K into K into K will give you what? K cube. So I know the diagonal, I know the determinant, so I can easily find out the determinant of the adjoint. The first formula which I taught you. Determinant of the adjoint is determinant of the matrix A to the power n minus 1. So what is the determinant of A? I got it to be K cube to the power, what is n? It's a 3 cross 3 matrix. So 3 minus 1 will give you 2. So the determinant of this particular adjoint is K to the power 6. A very important question. Question number 13. So please copy this. Please copy this. Okay, now we move on to the next question. Now this particular question number 14, 15, 16, these are all from the properties of determinant, which I've already given it to you. Question number 14 says, everyone, if A is a square matrix of order 3, so n equal to 3, and the value of the determinant is given to be 2, I have to find out the value of adjoint A. I have to find out the value of adjoint A. So the formula, that I had given, adjoint A is determinant A to the power n minus 2 into A. So this is the formula. What's the determinant A? It is 2. What is n? Order is 3. So 3 minus 2 into A. So 3 minus 2 is 1. So 2 to the power 1 is 2. So adjoint of adjoint A is 2A. So these formulas I've already given in the 20 formulas which I had done before I started this. So this is question number 14. Now question number 15. Question number 15 says, if A is a square matrix of order 3, the order is same, such that the determinant A is also given to be 3. Determinant of A is given to be 3. Then you have to find out the value of determinant of adjoint A. I have to find the determinant of adjoint A. So for this also there's a direct formula which is determinant A to the power n minus 1 whole square. So determinant A we already know 3, power is 3 minus 1 whole square. So 3 minus 1 is 2, 2 2s are 4. So 3 4 times will give us 81. 3 4 times will give us 81. So this is question number 15. Okay, question number 16. Question number 16 says, if A is a square matrix of order 3 such that adjoint of 2A equal to K times adjoint A. I have to find out the value of A. Now everyone just see, this is adjoint, this is a scalar. Okay, so remember, whenever there is a scalar inside a determinant, the scalar comes out. Similarly, whenever there is a scalar inside an adjoint, the scalar comes out. So it becomes 2 comes out to the power n minus 1 into adjoint A equal to K times adjoint A. So adjoint A and adjoint A gets cancelled. The power of n is 3, so 3 minus 1 is 2, so 2 2s are 4, so k equal to 4. So in this case, the value of k equal to 4. The value of k equal to 4. So this is question number 16. Question number 16. Now look at question number 17. Look at question number 17. So we have completed question number 16. Now question number 17. So tomorrow we are going to do the next set, that means from 21 to 40. Is that clear? Okay. So question number 17. The question is, if A is an invertible matrix, invertible means the inverse exists, then they are asking us what is the value of adjoint of A transpose. So same as inverse, the transpose comes out like inverse also, like see what is determinant of A inverse, the inverse comes out, isn't it, determinant of A to the power minus 1. Similarly, adjoint of A transpose, the transpose adj, yes, the transpose comes out adj to the power A whole to the power t, whole to the power t. So they can ask you, they can give you one practical question based on this also. So they can ask you to find the adjoint of an A transpose. They can tell you to find out the adjoint of A transpose. So what you can do is you find out the adjoint of A, then you take the transpose instead of finding the adjoint of A transpose. Is that clear? Okay, so this is question number 17. Question number 18 is also theoretical. So they are asking us what is ABC to the power inverse. So I've already told you the inverse will go inside provided the extreme numbers, extreme matrices change their places. So the extreme matrices are what? A and C. So the position of these two changes. So it becomes C inverse, B will remain as it is, and A inverse. So the right option that I see out here is option number C. Option number C. I've already told you many times that the MCQ questions that you are going to get, there will be 6 to 7 questions which you can solve without using your pen also. So I have shown it to you while doing questions on matrices, some questions. So these questions could be one of them. Okay, so question 18 also done. Now we come to question number 19. Everyone look at the board now. Question number 19. Question number 19 is they just want to know whether you know how to convert an equation into a normal equation into a matrix form or not. So they just want us to find out whether you know how to convert a normal equation into matrix. So question number 19. Okay, question number 19. A system of equation, three equations are given. So x plus 2y plus 3z equal to 7. This is the first equation. Next, 2x minus y minus 5z minus 13 should take 13 that side because constant should always be on the right. So that is called 13. And a minus x plus y minus z minus 11 goes that and becomes plus 11. So I'll teach you how to find this also. Okay, so these are the three equations. So in this particular question they just want us to know whether you know how to write a normal three equations in matrix form. So in order to express this three equations into matrix form, I need to convert this equation into three matrices. Number one, capital A, that is called the coefficient matrix. What is in front of x? 1. What is in front of y? 2. What is in front of z? 3. Similarly, what is in front of x? 2. What is in front of y? Minus 1. And what is there in front of z? Minus 5. Similarly, in front of x is minus 1, in front of y is 1, and in front of z is minus 1. So this is A. Now we have capital X, that is called your variable matrix. Variables, okay. So variables, look at this. What are your variables? The variables unknown matrix x, y, z, but we don't write it horizontally, but we write it vertically. Reason, The matrix multiplication is always row into column. So if you multiply the first row with the first column, you get equation number 1. And the third is the constant matrix, the constant numbers. What are those? 7, 13, and 11. So the above equation which you see can be expressed in terms of three different matrices. Now these three matrices can be written as AX equal to B. These three matrices can be written as AX equal to B. How? Because when you multiply the first matrix with the second matrix, you get the third matrix. Now just replace their values. So what is the value of A? 1, 2, 3, 2 minus 1 minus 5, minus 1, 1 minus 1. What is the value of X? X, Y, Z. And what is the value of B? 7, 13, and 11. So the right option that I see out here is option number B. So this was question number 19. This one was question number 19. This one was question number 19. Okay, now move on to the next question. I'll just drop this. Okay, question number 20. Those who have joined late, please make it a point that you watch the recordings from the first. Okay. Question number 20. Everyone look at the board. Question number 20. If A and B are symmetric matrices, what does symmetric matrix mean? Symmetric means A equal to A transpose and B equal to B transpose. Okay. Then they are asking us what is AB minus BA. They are asking us what is AB minus BA. Now to check whether the matrix is symmetric or skew symmetric, the options are symmetric, skew symmetric, zero matrix. It can't be a zero matrix because we don't know what is A, we don't know what is B. For it to be zero, it has to be zero, everything has to be zero. And identity is 1001. So the option C and D is not applicable out here. So it's either option 1 or option 2. To check whether a matrix is symmetric or skew symmetric, we have to take the transpose of that matrix. So the transpose goes inside because there's a minus sign. So it becomes AB transpose minus BA transpose. So you know the transpose goes inside whenever there's a multiplication sign, but the position of the matrices changes. So this becomes B transpose A transpose minus this is B in front. So now it becomes A transpose B transpose. Since A, B are symmetric matrices, B transpose is nothing but B. A transpose is A. A transpose is A, B transpose is B. So AB minus BA transpose, you're getting to be BA minus AB. So I have to make these two matrices same to check whether it's symmetric or not. So AB is the first element, but AB is the second element out here. So if I take minus out, I'm going to get minus AB, sorry. If I take minus out, AB becomes positive and BA becomes negative. See, the matrix is same, but there's minus in front. So we say it is a skew symmetric matrix. So this is how you check whether a matrix is symmetric or skew symmetric. Whether a matrix is symmetric or a skew symmetric matrix. Okay, so uh, A plus A transpose. Look at, we still got time, so I will help you with few more questions. So this is question number 20. So solutions to question number 20, everyone. Solutions till question number 20 is there. Solutions to question number 20 are there. Okay. Now from question number 21, since we got few minutes left, in offline class I had done till 20 because they had to copy also. So I will just move on with few more questions. Then we are going to solve the remaining questions tomorrow when everyone will be there, those doing offline also. Okay, so this is question number 21, which says capital A is a square matrix whose value is cos alpha minus sine alpha. Then this is sine alpha into cos alpha. So this is given. So what is given is, if A is given, then A plus A transpose is identity. So A plus A transpose is identity. A plus A transpose is identity. Then I have to find the value of alpha. I have to find the value of alpha. So how do I do this? Simple. Put the value of A. What is the value of A? Cos alpha. Then we have sine alpha minus sine alpha cos alpha. What is the A transpose? Row changes to column. So the first row will become cos alpha minus sine alpha. Then second row is going to be sine alpha cos alpha. And what is the identity, everyone? 1001. So in class 10 you have learned, in the class 10 you have learned, whenever you have to find the value of an unknown, you convert the left hand side and right hand side into a single matrix. Okay, so how do you do that? Please help me out. Cos alpha into cos alpha plus cos alpha will give us 2 cos alpha, minus sine alpha plus sine alpha will give you 0. Sine alpha plus into minus sine alpha will give you 0, and cos alpha plus cos alpha will give you 2 cos alpha equal to 1001. So we have shown that the two matrices are equal. So when two matrices are equal, its corresponding elements will also be equal. So 2 cos alpha will be equal to 1. So 2 goes down. So cos alpha equal to half, and cos alpha, cos 60. Cos 60 is half. So cos and cos gets cancelled. So the value of alpha is pi by 3. So the value of pi alpha is pi by 3. Okay, I will just do till here, okay, because so many students are not there, because I had done only till 20 with those attending offline. So tomorrow I'll just let them know and tell them to attend also. So tomorrow, is that clear? So what you can do is you can try solving these questions on your own and just see whether you were able to do it or not. Okay, good night everyone.